All right, for this section, we're talking about solving inequalities. So a couple things. Sometimes when we're solving inequalities, we want to use graph it on a number line because it's the easiest way to quickly show what answers work. So it's not just one solution, but it's multiple solutions. And so if we use that with inequalities, we saw that with shading on a graph on an XY coordinate plane. So we use a solid dot if we're including the number. So that would be in like less than or equal to or greater than or equal to. We're including that number, and then we're saying the ones that are bigger than this or less than this. And a open dot means we're not including it, but you can go right up to it. So if it was less than 2 but not equal to 2, that means I can do 1.9999 repeating infinitely many times. And that would be included in my possible solutions. So it's not just the whole numbers, but all of the decimals and everything. So that's why the graph makes it easy to show the answer. So if I'm writing an equality that describes this graph, we see that we have a closed circle at -3. So we know -3 is going to be in it. And then we want all of the numbers, and we can represent numbers as x that are bigger than that. So all the numbers, all the x values that are bigger than or equal to x to -3. All right, when we're solving, the main rule that we want to remember is that if we multiply or divide both sides by negative, then we flip the inequality. And we're going to try to get the we're trying to get the variable on the left side and the number on the right side. And we'll talk about that, why we want to do that. So we're going to solve this kind of like an equality. We're going to multiply just the left side by -5. So since I'm only multiplying right now the left side by -5 and not both sides, I don't flip it yet. So I get -5x minus 10 is less than or equal to 3x plus 6. Then we're going to subtract the 3x over. So I get -8 minus 8x minus 10 is less than or equal to 6. Then add 10. -8x is less than or equal to 16. And then I can divide both sides by -8. Now, since I'm dividing both sides by -8, I'm going to flip that inequality, and I get -2. So I want to graph all the numbers that are bigger. My answer is all numbers that are bigger than -2. So we're going to put -2 on here, maybe one on each side. And we want to also include -2 in the answer. So I'm going to do a closed circle to show I'm including -2 and then the numbers that are bigger. And if you do variable inequality number, then this is like the arrow pointing which direction we're shading. But it has to be variable first. If it's the opposite, then it's the opposite way. So I'm going to shade to show all the answers that would possibly fit, because I can't name all those answers. All right, let's look at what's called a compound inequality. So that means there's two situations. And notice the word or. So if I say or, then I'm saying either you need to fit this restriction or this restriction, or both. But for sure one or the other. It'd be kind of like if I say you have to be under 18 or a heritage student to participate. So either you're a heritage student, I should probably have said it a little older, because most heritage students are under 18, then you can be in this, or you have to be under 18. So if you're 19 and a heritage student, you could be in that, whatever the qualification is. So I have 3x minus 7 is less than 5. So we're going to treat these different as their own separate inequalities. So I'm going to add 7. So I have 3x is less than 12. Divide by 3. X is less than 4. Or, and I'm going to do my other one, 4x minus 6 is less than 22. Add 6. 4x is less than 28. And divide by 4. And x is less than 7. So on the or one, we want the one that includes the most. So anything that is less than 4 is also less than 7. So in this sense, since it's or, I can just graph the x is less than 7. So it's an open circle because I'm not including 7, but I'm including all the numbers that are really close to 7. So notice they're both graphed. Less than 4 would be an open circle here and less, but we're include that would also fit the less than 7. All right, here we have another compound one, and this one has 2 situations, but this, when written like this, is an and. So you have to meet both of these. So if I said you have to be a senior and you have to be a heritage student for you to paint a parking spot in our lot, those 2 things have to happen. So this is a little bit more restrictive because it's not just a heritage student can do it. They have to also be a senior. So we're going to split them up like 2 different inequalities. So it's like we cover the last inequality, and we solve -2 is less than 5 plus 3x, and 5 plus 3x is less than 20. So we want here where both things are true, so where they both intersect. So I'm going to subtract 5 on both sides. And -7 is less than 3x, and then divide by 3. So notice I said at the beginning, when I'm graphing these, I want the variable first. So I'm going to go ahead and write the x first. Still going to have the inequality facing the same way. In fact, in that the open part is facing the x, but I'm just going to write it that way so it's easier to graph. And then subtract 5. 3x is less than 15, and then divide by 3. X is less than 5. So my numbers are those that are greater than -7/3 and less than 15. So -7/3 is like -2 1/3. So it's almost just a little past the -2. So I have -2, -3, and then we're going to put in all of the numbers to 5. So -7/3, we're just going to kind of put a spot here, and bigger would go this way, and less than 5 would be an open circle because we're not including it, and less. So this is the only part that we're going to graph is where these overlap. Nothing else. If anything else is graphed, then it's not quite right. So here we're saying it has to be greater than -2 1/3 and less than 5. But it has to fit both of those. So this is a little bit more restricting. Right.